or whatever else
Okay.
you're going to do. Okay.
All right, thanks. Thank you. All right, is everybody here to learn a little bit about Docker? Does everybody know what Docker is? I mean, there's a lot of press about it, obviously. It seems to be like the new hot technology that's out there. So I'm just going to be giving a nice little overview about what Docker is, how it can help you. By nature, I'm a system administrator. It's really helpful for developers, and hopefully we'll be able to explore that a little bit. About me, self-explanatory. I'm Mike Klatsky. I've been around the area. I've lived in this area in Western Mass for 30-something years. I worked for several ISPs, telephone company, TNR Global, and now Esperdyne Technologies. I love my dogs. I love brewing beer, which kind of helps me with the rest of the stuff. About Esperdyne Technologies, I'm not going to go read through the whole thing. I think you can read it yourself. But where several of us have been in the industry for, I mean, I think collectively probably about 80 years together. So there's a lot of experience, a lot of highly specialized experience in cloud technology, search technology, development. Got several high-profile clients, and I guess this says it all too. What's Docker? It's a lightweight container system. And what is that? A lightweight container system, a container eliminates the overhead that's associated with virtualization. When you have virtualization, I don't know if you're familiar with Vagrant. I think there's another workshop on Vagrant here. Vagrant uses VirtualBox. And what that does is that adds, on top of your operating system, it adds a layer of virtualization, and then you work with that. So you're actually running kind of two operating systems on your server or on your desktop. With a container, the container only introduces the specific items that are required for your application to run. So if you need PHP, let's say you need PHP 6, the container will contain PHP 6, and it doesn't matter what's running on the underlying operating system because it's a container, it's self-contained. So it only contains those dependencies that you need. It's also portable. You can move a container from one server to another server, and that's relatively easy to do. It's also a dream. The reason I say it's a dream is, let's say you have an application that currently is running on PHP, let's say it's running on PHP 5.2, and you need to bring it up and you need to have it run on PHP 5.5 or PHP 5.6. You can actually build a container with PHP 5.5 or 5.6 and run your application against that, and it's all in one container, and you can see how it breaks, it will break, and then you can fix it, and you can keep on iterating very, very rapidly. Because of the nature of the way containers are built, once you build it the first time, every time you iterate through that build cycle, it's much quicker the next time. So the first time may take a few minutes. Some, depending on how much stuff you're packing into that container, could take 20 minutes. But the second time, it may only take 10 minutes. And then after that, I've got some builds that iterate in seconds. They're so fast because I'm changing small items. Very helpful for rapid development. How do we use it at Esperdyne? We use it for our internal systems. We use Redmine. Redmine authenticates against LDAP, and we have a whole bunch of other applications that we run using Docker as well. We just had occasion to have to develop a very highly specialized service. We didn't want to deploy a new cloud server, an Amazon server, and rather than doing that, we built a container which ran the service. It was up, we took it down, and it was running on a system that was a little bit older but had the kernel that we needed to be able to run the container, which is pretty much any modern distro, CentOS 6, Ubuntu 13.10, 14.4, any of the newer distros will have it. Again, I mentioned the rapid testing of apps with various dependencies, and you can easily scale apps from single instances to multiple instances. There's a tool that I mentioned at the end that I'm not really going to go over too much right now, but with one command, it allows you to scale a service. You can just scale it up for an additional 1 container, 2 containers, 5 containers, you're only limited by the resources on the underlying server. And since containers run very efficiently, you can actually run quite a few containers on a server. So today, we're going to learn how to install Docker. We'll learn how to run it and the basic tasks associated with running the container. Learn how to deploy a Drupal instance using Docker. Learn how to upgrade Docker. I'm going to do a very simple upgrade in the interest of time and just kind of giving you an overview. I'm not going into all the internals of Drupal or upgrading Drupal, but I just kind of put something together quickly to give you an idea. And learn how to migrate a container from one host to another. So if you want to install it, and by the way, what I'm presenting up here, if you go to the Nerd Summit site and you look at this presentation, there's a link to the PDF which has all of this information so you can run these commands to do it if you want. It's installable on OS X, but OS X doesn't have a Linux kernel, so you actually have to run Docker on a virtual instance, on a Vagrant container. And there's something called boot to Docker that handles all that, so you don't have to bring up your own, you don't have to build a Vagrant instance, you don't have to run that separately and then SSH into it to run Docker. Boot to Docker handles it all. On Linux, the distributions all have packages for it, CentOS 7, CentOS 6, there's a naming conflict with something else, so it's called docker-io, but the binary, you still run Docker the same way. By the way, if anybody wants me to halt or stop or anything like that, let me know, because there's some commands in here that if you want to type them out, you can, and we'll wait. But if not, it's probably good to get the PDF and copy and paste it. Docker runs on Windows. I don't use Windows, so this is just specifically from the Boot to Docker site. My experience for the last 20 years has been with Linux and with OS X. But this is, according to the instructions and people I know that use it, this is a full installation of Boot to Docker for the same reason that we have to do Boot to Docker on OS X. So let's run a container. When running a container, Docker will search locally for an image. It'll download one from the Docker registry if it's on the Docker registry and if it's not found locally. If you punch in a name that the registry doesn't know about, and the registry is very much like, you know, with Perl and CPAN, Python, you know, pip, that type of thing. It's a registry which holds, a lot of people put up containers, we put up containers. They're publicly available. Like anything else, you also want to know where that container is coming from. A lot of people put up development containers, and you don't know where they're coming from. You don't know their provenance. So for CentOS, I prefer to use the official CentOS image. And if you just do Docker search CentOS, it'll bring up a million different CentOS images. But if you say Docker pull CentOS, it'll only pull the official CentOS image. So if you do Docker run CentOS or Docker run Ubuntu, and I'll see if I can do that now. What'll happen is that. We'll just get this running again. All right. Okay. I'm just going to go to the next slide and pull the information off of that. Anyway, what I missed is a couple of flags on it. Docker run CentOS and Docker run Ubuntu with the proper flags, -T, -I. It'll run it, and then it'll exit the container very quickly, because with a container, what you have to do is you have to actually run a process in the foreground. The container is essentially just a bunch of files and the parts of the operating system it needs that you don't have in the underlying operating system. So if you do this, this should run the Docker container. So now we're in a container, and we're running Red Hat or CentOS 7.0. So we're not on the underlying server right now. We're running a container. If I do the same thing, but I do it with Ubuntu, I'm now in an Ubuntu container. You can also see how quickly it takes to spin it up. When you run this, and what we're doing is we're running it. The -T means run to TTY. I means interactive. Ubuntu tells it the image that we're using, which is Ubuntu. Bin bash is a command. You have to run a command of some sort. The RM tells it to clean up after itself. So when I exit this container, the container is gone because we don't really want it anymore. If you do that, you'll see there's nothing there. So that gives you a brief idea of just the beginnings of a container. So now we're going to deploy a Drupal container. I've already pulled these images, so they should be here. We've got MySQL, we've got a Drupal 7.28 version, and we've got a Drupal 7.31 version. So we're going to do both of those. We're going to run both of these commands. So when we run this command, just to go over, let me clear that screen. When we run the command, the flags on here are, we're telling it that we want to expose the port, the P3306, 3306. That tells us we want to expose the container port, which is 3306 for MySQL, to the underlying host itself so that other containers can talk to it. The -V, what we're going to do is we're going to mount op MySQL within the container. We'll get into this later, but if we don't use that -V, anything that you do on this MySQL container, all the data is contained within the container. So when the container dies, when you stop it and when you kill it, all the data goes away with it. Not very helpful if you want the data to persist. So by exposing the underlying host, that one directory, into the container, all the data is stored on the host. What it means is you kill that container, you can also bring up another MySQL instance, either the same one or a different version, and it can use the same data, barring any upgrade inconsistencies, that type of thing. We want to name it because it uses, when you run containers, they're actually named with a long hash. It's easier to use the name DB when you're trying to link to it or when you're working with it on the system, rather than having to use a long hash. And we're setting some environment variables here. The environment variables are MySQL user, your password, things like that, and you can take a look at what's needed within. There's the hash that I was talking about. However, we want to know it as DB. I'm going to try making the font a little bit smaller. Because we're not seeing the full. Can you still read this? Is that still legible? Okay. So if you look at the far right, you see it says names DB, shows the container's up. It shows some basic status about the container. And if you look at the container, the command where it says user local bin run, that's just a script built into the container, and that just tells it to run MySQL. Without that, we wouldn't have a container that stays up, because it'll just go up and then come right back down because there's no foreground process running. And when I say foreground, it's foreground within the container. It's not foreground, as you can tell, it's not foreground on the instance itself. So the next thing we're going to do is we're going to bring up Drupal. And I'm going to bring up the 7.3.1 instance right now. Actually, I'll bring up the 7.2.8 instance. So you can see how quick it is. Once you see that hash, that means the container is running. and you can verify by looking at it here. So what we've done is we brought up a MySQL container, we brought up a Drupal container, or a container that has Drupal within it, and we've told the Drupal container to talk to the MySQL instance. And so what we can do now is, if we run this, this will bring us to the, if you're familiar with Drupal, I'm sure a lot of people are, this will bring you to the familiar installation profile. I've already populated within MySQL and within Drupal, I've already populated it with some of the stuff you put in for the database, all the environment variables for the database. So what should happen is I'll get through this part. Oh, it's not there. All right, so I'm going to try to put this in here. And I'm just going to type DB for the database host. And assuming this works correctly, okay, so now we're not in admin. So anyway, you can see that there's a Drupal site that's up just from running those two containers. I persisted data earlier when I was testing this, I persisted data to the host. So it's pulling the data from the host, and that's why it's not going through the whole process itself as it should. But you can see how quickly those containers come up. And this is what we did for linking the what we just did by linking in the Drupal container to the MySQL container. So to upgrade, what I would typically do is I'm just going to kill the Drupal container, and if we look at the PS, we see just the DB is up now. So the next thing I'm going to do is I'm just going to run Drupal 7.31, and that should do the same thing. So if I go back to the browser, and the reason I'm doing install, if you've ever run Drupal and you've tried to set your own settings PHP file, instead of letting the installer do it, it kind of goes crazy and it's missing some tables and it gives you an error. It won't automatically go right into it. So you run through the install, and see, since we already have the MySQL data running and MySQL is already running, again, it knows that it's there, and it'll bring you back into Drupal, and this is 7.31. However, we have a problem. I discussed this a little bit earlier. I got ahead of myself. If we delete the container, if we delete the MySQL container, we're going to lose the database info. So if you lose the database info, you have to run through everything all over again. So if you rebuild the image, let's say you want to rebuild the image using Drupal 8, or let's say you use MySQL and you rebuild the MySQL container and you bring it up with MySQL 5.6 instead of MySQL 5.5, you'd have to kill the container, restart it, and you'd lose all of your data. Well, by exposing, as I showed earlier, with that -v command, exposing the host directory into the container, you don't lose your data. And you can also back up that data in a little bit different fashion than you do with Docker containers. So back to the -v, that's what I was just discussing. And we just run the same commands that we just did, and the data will stay on the host rather than in the container. There are common tasks that you run using Docker. Docker version helps for me to type. Just shows you the client version, shows you all the particulars about what you're running. It'll also come up and it'll tell you if you're outdated. You always want to use the latest version of Docker. There are additional things that they're adding all the time. One of the things that is that they can do, that you can do now, which you couldn't do before, is there's a flag, cape on and cape off. You can enable capabilities for networking, and you can turn off capabilities for networking, among other things. That helps with security. You can Docker inspect container. That shows you all the details about your container. It shows you where on the drive the information lives, shows you everything about networking. It'll show you your environment variables, host path, all the details that you might need. Shows you your networking information, anything, volumes, if there are any volumes. It's useful for pulling information to use with other containers. Then you've got Docker stop, Docker remove, Docker PS, which tells you the running containers. Docker PS -A tells you not only the running containers, but containers that have run but have exited. So they're still there, and you can start them up using a Docker start. And then information about images. More information is available at that URL. That's Docker's whole reference for their command line. Building containers. A container is built using something called the Dockerfile, which just describes what packages have to go into the Dockerfile or into the container, information about what image is its source image, because you always start with the source image, and additional information such as commands. They can be simple or complex. This is a complex one. It looks a little bit better if you're looking at VI in a window, but this essentially builds a Drupal instance. And let's see if we can just quickly build a Drupal instance or Drupal image. So this is the Docker file in VI, and you can see essentially what it's doing is it's downloading Drupal, it's expanding it, it's tossing it into place, it's adding a couple of packages. Anyone familiar with doing basic system administration work should recognize just about all the commands. And we're running Apache under supervisor, and that's because if Apache dies, which sometimes it does, the container would die with it. So supervisor always runs in the foreground and will keep Apache going. So it's a little bit of a kludge for the way a container operates, but it'll keep that Apache instance always running. And so to build that, we're just going to go ahead and run docker build. And this one is about 350 megs or so. And this should be familiar to anybody who's familiar with Debian or with Ubuntu. It's just going through and doing the install. And so it goes through here. It's going to grab the information. It's going to grab the packages, the Drupal packages that it needs. Let's say there's a dependency that you need that's very, very specific. What you would do is you would go in and you would just add that one item into your Docker file, rebuild it, and it'll roll through and do it even quicker the next time. Now it's downloading Drupal and expanding it, and now we're done. So now we have another Drupal image that's been built, and you can see the images by typing Docker images. And even though this says 6 days ago, that's because of the history of the Docker image. I first built this one 6 days ago. The only thing that changed was a couple of things I put in for the apt-get update, so it had to rebuild that part. So the ancestor is from 6 days ago, but this is what we just built just now. And you can tell that because it says latest. I didn't add a tag to say that it's 7.31 or 7.28. So latest is always the most latest build. So this is an example of a complex one. This is a simple one. If we built this, all it's going to do is install Apache, and when you run the container, it's going to automatically run Apache. And you won't have to add a command either. And the reason I say that is we have commands and we have entry points in a Dockerfile. A command will automatically run when you run the container built from this. However, you can override it by putting another command, and it'll ignore that command that's built in. When you have an entry point, the entry point cannot be overridden. So no matter what you do, you can't override that user has been Apache, and then a command becomes just an argument to the entry point. So when you're handing a container to somebody who doesn't know how to use Docker, you just want them to deploy it, entry point would be a good way to set that up for them. To upgrade the build, we kind of just did it, but in, for example, Drupal, this section where it says 7.28, 7.28, all I would have to do, and this is what I did, was change that to 7.31, and I rerun the build. It'll go through, do everything the same, except it's going to go and grab the 7.31 Docker Drupal packages, Drupal tar file instead of the 7.28, and it'll build that into the instance. So it's pretty quick, pretty easy to do that way. And you can always roll back. If you upgraded and it didn't seem to work, you ran into some incompatibilities. Lots of times when you upgrade Drupal, you run into module incompatibilities. It's very easy to roll back. You just rerun the container that was already running, and you're back at your old version. Copying a container to a new host. This gets to the portability. Where does portability come in handy? Well, one place it comes in really handy for us is with Amazon. AWS EC2 servers, I don't know how many of you are familiar with working with them. We run hundreds of them, many hundreds of them, and they always go away. You get notices, sometimes they just disappear on you. If you're running containers, if an instance goes away, you can very easily bring those containers back up on another instance. And then all you're worried about is DNS, but you have that automated too. So makes it pretty easy. One way of exporting a container with the data is you do a Docker export, in this case db new tar, copy the tar file to another instance or another server, and then you just import it and you run it, and there you go. When you do that, you've got your container on another instance. It's that easy to do it manually. You can also do it, as we've seen, we've done the Docker polls. That's the registry service. You can run your private registry yourself, or you can use their registry. You can have a new server automatically pull from the registry, and that can be done in an automated fashion, depending on how you set up your servers. There's some additional tools out there. One of them is called Fig. Fig is what I like to use for single container launches. The reason is it's just a YAML list, and it just describes all the information about your container, about your images, your containers, and makes it easier to work with Docker. It makes it more repeatable. Instead of having the long commands, you just run fig up, fig down, fig rm, and it knows what containers you're talking about. It'll set up the links for you automatically. It's well done. Fig was part of the Orchard. Orchard was purchased by Docker, so now that's all in-house. Something new that my cohort over here, Mike McIntosh, showed me is something called Kitematic. If you're not a command line person, Kitematic basically uses boot to Docker on your Mac. It's Mac only. But it's a GUI version of boot to Docker. So you can create your images, you can run containers, all within a pretty nice GUI. If I'd thought ahead further, I'd have a nice screenshot of what it looks like, but it's pretty sweet. More reading, CenturyLink Labs, which is, I've come to know them for their Docker posts because they've got a huge number of wonderful Docker posts, but they're a network provider, data center, and whatnot. But they're doing a lot of work in the Docker space. Kartar, the Docker book, if you buy the online version, and if you buy it through kartar.net, he upgrades, adds chapters all the time at no charge. It's relatively inexpensive. I'd recommend, this is not a knock against Amazon or Kindle, but if you buy it directly through Amazon, they don't upgrade or update the book as often. he updates pretty often, and then you just download the new version, and you're all set. And he's just introduced a couple of new chapters on some additional features that Docker has for running Docker containers on multiple servers across multiple data centers, that type of thing. And I'm not sure if it's gotten to the Kindle version yet, so I'd get it directly through him if you want to get that. The website for Docker is right there. Some guy that I don't know, but his name is Thomas Uhrig, and he's got some really, really cool posts on Docker. I've seen his name about, but I don't know him personally, but I like the stuff that he writes. And DigitalOcean. DigitalOcean is another provider. They do things really, really well, and they've got a lot of good tutorials and blog entries and whatnot. So a lot of good information there, and this just touches the surface of it. Contact info, I just scratched the surface of Docker. A couple things didn't work exactly as I expected, as you can see, but I'd be happy to talk to you in more depth at any point. Email me, give me a call. I'm Mike Klatsky again, Esperdyne, and thank you. If anybody has any questions, go ahead.
So I noticed in the beginning you had 2 Docker instances, well, 3 of them. You had Drupal 7.2.8 and 7.3.1 and
Yep.
MySQL instance.
Yep.
What would is there a chance of putting the MySQL instance pre-populated with all of the data for the Drupal instance in the same container, so you deploy it and you have like a...
You can do that. It's not generally recommended, and the reason is containers are made to run one process, and if you put and this is theory. It may not always work in practice, but in theory, you want to run discrete services and discrete processes in a container. So you can put MySQL and Apache into one container, but then you'd have to be running 2 processes. You can't run Apache and then run MySQL. You'd have to script it, and you could build that in to run both items in the foreground. But where Docker is really good is in its portability and in your ability to upgrade very easily and make modifications really easily. So if you have MySQL and if you have Drupal, if you want to upgrade Drupal, you're only upgrading the Drupal code. If you want to upgrade MySQL, you're only upgrading the MySQL code. If you pack it all together, then what you've got to do is you've got to upgrade the entire thing. And you could do it, and in fact, if you do a search on the registry, you're going to find containers that are full Drupal LAMP stacks that run the whole kit and caboodle in one container. But you then can't split them off into different hosts. You can't split them off into different containers. If you use MySQL in Drupal in one container, and let's say you have WordPress, you're going to have to find MySQL for that WordPress container as well. Whereas if you use one MySQL container, it saves time. It makes it easier to manage. You can manage your backups easier because you're only backing up one MySQL container. You can have WordPress and Drupal talk to the MySQL container. It's kind of the Docker way. Like I said, you can do it, and people do it. And I've certainly done some containers where it's running a couple of things. In fact, Redmine is running a couple of different items within it. I didn't separate everything out because in that case it was easier to do. In fact, MySQL is running in that Redmine container. It's something I'm going to be changing, but at first it was just easier to do it that way. But LDAP for authentication, that's elsewhere. So, yes.
Just to expand a little bit, like one of the things that Michael and I have been talking about, like specifically, we deal with a lot of service-oriented architecture. So a place where the Docker containers are really useful is, we're switching from a modality which we had years ago, which was server-centric, machine-centric, and now almost everything we look at it as a service is a number reason why. We like to put things in separate Docker containers, although as a developer, I'm much more assistant than I'm a developer. I understand wanting to bundle everything together. So if you do bundle something together, despite that not being best practice with Docker, you need to use like a process manager like Supervisor or something like that to
Yes.
Just walk through, a little unclear about, if you have a container, this has an underlying dependency, and then you want to say it's an Ubuntu and you apt-get update. How do you take that container and update that dependency? Does it generate a new version of that container? Say that it's something, you had a dependency on SSL or something.
Right.
The version went up.
Right.
Is that generated from that one container? Is there a
What
new version of that? How do you create that new version?
what you would do ideally is you would just update the build on the container. So you go back to, and hopefully it's all in version control. What you would do is you go back to your Dockerfile and you just do a Docker build, and it'll rebuild the container with the updated dependency, and then you stop the old container, kill it, and then restart it and it'll use the latest image, and that'll have your updated dependencies.
Same container name, system version.
Yeah, exactly. Now, you can, this gets a little bit out of scope for what I wanted to talk about, and goes against the Docker way. I mean, we all deal in the theoretical best way of doing things, but then we also have to deal with the real world of doing things. So one thing you can do is you can actually enter a container, and in that container, you can do an apt-get update, and you can upgrade in place while the container is running. The problem is, when you kill that container, you lose that update, because the life cycle of the container is very temporal. It starts, it stops, and it goes away. And whatever's in it goes away. The only thing that persists is the image that it's built from. So it's not ideal to go into the container and do changes and do updates, and then get out of the container and leave that running, because now all of a sudden you have a container that's not in a consistent state from what you thought it was. It's very easy, someone will forget that you did upgrades in place, that type of thing. So it's best to just rebuild it, and that replaces it in your internal registry. So for example, that Docker build that I did, let's say I wanted to, instead of PHP 5, do PHP 6. So in the apt-get line, I'd say apt-get install PHP 6, and rebuild that container with the same name, unless you change the name, but it rebuild the container with the same name, only it'll have PHP 6 in it instead of PHP 5. And then you stop the old one, start this new one, boom, you got your upgrades in place, and they persist. So, any other questions?
What distro are you
It doesn't really matter, but we're running right now. I'm running on what you're seeing here. I'm running on my laptop. It's OS X, and it's just an Ubuntu, a minimal. Actually, it's not even Ubuntu. It's like a tiny distro of Linux. But we're running Docker on. We're running it on Ubuntu 14.04. We're running it on CentOS 6. And there are a couple of distributions out there that are specifically made for running Docker. One of them is called Koros. And Koros, it's like a bare metal thing. You don't even want to use the underlying operating system for anything. It's got built in some advanced features that get into service discovery called Fleet and etcd. And that allows you to do automated service discovery. So when you bring up an instance, or when you bring up a container, it registers itself. And if you've got a proxy running, something like HA proxy can become instantly aware of that new container. And this gets into the portability. You bring up the container somewhere else. Again, it registers with etcd. HA proxy is aware of the new location, and you have seamless upgrades or seamless scalability, that type of thing. Did that answer your question?
guys have experience with that stuff?
Yeah. We've been doing a bit. I mean, how long have I been working with it? 6 months, 7 months, at least, with Docker. Yeah.
And we've been dealing with other systems, looking at done many iterations, or we use a lot of virtual DB. This is like really simple.
How
Yep.
many Dockers are we running on?
We're actually
Services?
we're actually the most number of containers that I've run. Benchmarking, I ran something like 150 on a host once, and the load increased when I was running web servers on all of them, and I was running about 5 or 6 MySQL containers. The load increase was minimal. I mean, it was much less than running that number of sites on one server. In practicality, I think we're running 10, 15 containers on regular medium-sized Amazon instances. Yeah, and we're not pushing it. I mean, we've got plenty of. If I look at the load graph, there's no load graph. I could ride my bicycle on it very easily. It's so flat. But they're really, really efficient because they utilize all of the underlying libraries that are not necessary to the container itself. So they share everything. It's basically a copy on write model. So it just reads the libraries, uses the libraries. Only when you change something does it have to make a copy and put it into the container. And it's also similar. The AUFS file system is similar to what Parallels has been using for their proprietary OpenVZ. We also have used OpenVZ for quite a while, which is the open source version of Parallels for servers. And we've been able to export OpenVZ containers very easily into a Docker container. So it's just, I think it's one of the most exciting technologies that's out there.
So, some of our clients are dealing with proprietary technology that we have. And one of the things that I'm looking at is how we migrate down from some of the newer open source stuff. And just to give an example, like one of our search customers might have 40 machines in it, which in aggregate is running like 300 services across the entire cluster. So things like having to do it the old way and having to do upgrades, all that stuff, has been very painful over the years and stuff. So some customers like that do the proprietary nature of the software. But stuff like Docker let us retrofit a lot of the work that we're doing so that we have access and we use the newest technology, so parts of it are legacy. So it's just incredibly powerful like that. And the other thing is staging, from a staging standpoint, like, just as a developer, like, now, I'm excited when we use Docker because, like, I can test something on one server or flesh it out even locally and wrap my brain around how all the services have to interact. And then in the real, production environment, we can deploy multiple servers, multiple services per server, and just completely maximize.
Right, and you can keep, Google has some cool tools for monitoring out there because Google is they're almost all Dockerized containers and various, varieties of them. There are a lot of companies now that are just running almost completely Dockerized. A lot of startups are doing it too. And in your monitoring, you can keep an eye on your host and just keep on adding containers until you start seeing a load that gives you a problem. I've read people running hundreds of containers on servers without any kind of a problem. And you can isolate the loads. You can also set CPU limits and memory limits. So let's say you run 100 websites, each site in its own Docker container on a server. Now we get into a model of if one site gets DOSed, only that container is affected, not all the other all the other sites. And we know what Apache can do when one site gets DOSed. Goodbye. That's always fun.
You're talking about multiple web servers. I was wondering, do you see anything with how does the file descriptor limits work? I got to wrap my brain around this. Is it limited by the host operating system?
It's limited by the host. So that that is a limitation that's there. You can, I believe, with this version of Docker, you can limit how many file descriptors are available to the container itself. But other than some, with the newer distros, other than some of the stupid defaults that we still see out there, it's been a long time since I've seen file descriptors become an issue. I think in MySQL, it's become an issue with a couple of systems that we ran that we had to address. But that just meant upping the limits.
Yeah, more interested like in node-based servers where you keep it
Right. Right. I haven't run into that. We use Node.js for a couple of things. I haven't run into anything like that, but it's certainly something. It's something that's monitored, so you can keep an eye on things. Yes.
So what hiccups or like gotchas have you guys
Have you just seen
Everything ran.
to the screen?
Everything ran perfectly, no problem, including the Drupal thing before. I don't know if you watched while we were doing the question and answer. I ran through the install process and it worked properly. What happened before was when I instantiated the MySQL container, I was using data that already lived on the server and the host container and on the host, so it didn't quite know what to do. So I wiped that out, brought up a new container with no data in it, and it went through the install. It knew what to do. So that's the kind of hiccup you'd run into, a little thing like that.
Crashing, high load, these sorts of.
We haven't seen anything like that, but honestly, that's because the stuff that we're doing doesn't really push the containers to the limit. There are a couple of places where I'm not using containers. One of them is, I don't know what people are used to using, Chef or Puppet, or maybe SaltStack for configuration management. We use SaltStack, and my SaltStack master, I'm not comfortable running in a container because your SaltStack master, it pulls all of its information from a Git repository. Well, I don't want a container changing all the time because that kind of defeats the purpose of having a truth. So that container, if it stops and you bring it back up, now all of a sudden it doesn't have stuff that the other one had, so you're inconsistent. So there are a couple of problems I need to solve before I'm comfortable running SaltStack in a container. We also run for monitoring. One of the monitoring systems we run is, if you're familiar with Nagios, there's something called CheckMK, which takes Nagios further and is pretty cool. And then there's another distribution called OMD, Open Monitoring Distribution, which just packages up CheckMK and a few other things really, really nicely. Well, you can run multiple users or multiple companies or multiple environments within that monitoring distro, and that again means making changes to a running system. And so I haven't quite figured out the right way to put that into a container. I don't want to run discrete Nagios services. I don't want to run in containers. I don't want to run Nagios right now, because that introduces your monitoring system. You want as direct contact with the systems it's monitoring as possible. So I don't really want that in a container right now. So those are two cases where I don't necessarily know that Docker's appropriate yet. For almost everything else, I love it. Hiccups, just some of the learning curve. Once you get, the biggest hiccup is moving from single host to multiple hosts. That's the biggest thing. Where are your containers? Where do they live? What's the best place to put them? How do you know where they are? How do you do automated DNS? How do you make, if you're running a proxy for things, how do you let the proxy know where the containers are and how to talk to each other? So that's the biggest thing. It's not really a problem. It's just part of the learning curve, getting to that point. Other than that, I haven't really seen I haven't seen many problems. Nothing where like all of a sudden this thing is dying on me and I can't figure it out. Nothing different than when you're deploying any other server anywhere else. And gee, why does Apache keep crashing on me? Well, why is each Apache child, a gigabyte in size? Something's wrong. So, I think you had another question.
So what's the separation?
Yep. That's it. Well, are you familiar with LXC containers? Okay, so it's basically that. Although they've made a change, they're not using LXC as by default. They're now using their own lib container, and so they address that a little bit better. A couple of months ago, there was a big issue that came out in that under the right circumstances, since up until recently, in a Docker container, a process ran as root. The container itself, since the process in the container was running as root, if you expose the host file system into the container, it could then, for want of a better word, latch on to root on the host. And it blew up. It was a big thing a couple of months ago. They've addressed that so that now you can drop privileges once the container starts. And you can also tell something to run as a specific user. So Apache runs as www-data or Apache. So you can set it so that the container cannot run as root, and that eliminates that privilege escalation. So it was an issue, and they're still addressing other things. That's why you can limit capabilities using certain flags. So the privilege separation, I think, is fine. But that gets back to when you download images, you want to make sure you know the provenance of those images, because without any vetting, who knows what's done on the image? They could introduce something possibly malicious. But done properly and done the way Docker is doing things right now, the maliciousness now is limited to the container itself. So there's more reading on it. The Docker site has a lot of information about that, what they've done to address. Time? You had another question? Sure. Well, they're different. I mean, Vagrant is a way of deploying VirtualBox instances. So you're running a full virtualization layer. So you're running an OS within an OS. And I use Vagrant all the time. It's not meant to replace Docker, but if I want to run 7 web servers, or if I want to do this, I want to do Drupal, and I want to do rapid development in Drupal and have it run on a server, I don't want the overhead of VirtualBox or VMware running full virtualization or para-virtualization on a server, and then you're running your process on that virtual server. Container dispenses with that. It eliminates the virtualization layer, so it's actually using the resources of the host itself without the additional layer. So it's lighter on resources and it's faster. But not a knock against Vagrant. I use Vagrant all the time. So, and in fact, I'm using Vagrant on my laptop because Vagrant is what's running the VirtualBox instance, which is running my Docker container. Because the bottom line is Docker absolutely requires a Linux kernel. So if you don't have a Linux kernel, you have to jump through a couple of hoops, which have been made very easy. But on the technical level, you have to jump through some hoops to be able to run Docker. So, all set? All right, thank you.
All right.
Sorry, I got stuck at my...
Yeah.